All right, so thank you so much for the great introduction. So yes, my name is Chantel, and currently I'm located in Montreal, but if you heard that I studied at the University of Manitoba, so I'm actually from Winnipeg, but I have family in Calgary. So in my childhood, I definitely took quite a few road trips on the Trans-Canada Highway west of Winnipeg to go to Calgary to visit family. So it's a very special place to me. And I was very honored to be invited to speak to the RASC Calgary group today. So I don't like to assume what you know about the Canadian Space Agency. So I'll tell you a little bit about us and what we're doing. So the Canadian Space Agency is Canada's national space agency. We are a branch of the federal government, and we're civilian in nature. So really our mandate is to advance the knowledge of space through science and to use that science and those discoveries for the good of Canadians and ultimately humanity as well. So if you didn't know, our headquarters is located in Saint-Hubert, Quebec. So this is just outside of Montreal. And we call this, our headquarters is called the John H. Chapman Space Center. So that is our main workplace. We also have a couple of other locations that are a little bit less well known. So outside of Ottawa, we have the David Florida Lab. So this is a really large facility that's used for testing different spacecraft, including some of our satellites, like the radar constellation mission. They do tests like thermal testing, vacuum testing, and those sorts of things for both government missions and for commercial missions as well. We have an office in Gatineau, Quebec, just on the other side of the river. So this office is primarily supporting what we call policy activities, so international relations, domestic regulation, partnership with industry and academia. And not on this page, but we do also have one room offices as for our liaisons, one in Paris, that is our liaison to the European Space Agency, and also one in, I think, Maryland, which is our liaison to NASA. So we're a little bit more spread out than I think a lot of people realize. So that should give you a little bit of an oversight of us. So I also like to mention John H. Chapman. So our headquarters is named after this engineer who actually was part of the first Canadian space mission, which is the Alouette satellite. So it was it made us the third country to actually design and launch something into orbit. And I really like this quote by him. I think it really encapsulates, what the Canadian space program means to Canada. And he said, in the second century of Confederation, the fabric of Canadian society will be held together by strands in space just as strongly as railway and telegraphy held together the scattered provinces in the last century. So he really believed that communication satellites would be really essential to our future as a country that is very vast and has many communities spread across it. So our activities can broadly be separated into three pillars. One is space utilization. So this is things like Sun-Earth sciences. It deals a lot with our Earth observation missions, upcoming missions like Wildfire Sat, and current missions that are being operated. So our operations team for these satellites exists within this group as well. So this team is operating NeoSat, the radar constellation mission, and future missions as well. There's also the Space Science and Technology Directorate. So they're mostly dealing with the development of technology and science applications. A couple of really interesting projects that they have going on right now is Stratos, which is a stratospheric balloon program, which seems kind of funny to be mentioning right now, given the climate, but this has been going on for quite a few years. And what this group does is we actually work with the French space agency called Canadensys to launch stratospheric balloons. These usually carry scientific payloads that are sort of like proto-flight. So they're not going into space, but they're going just below space. And that is a really good environment for doing some technology demonstrations and collecting data. We also have the CUBICS program, which was it's sort of like the next generation of the Canadian CubeSat program. So the Canadian CubeSat program was an initiative that allowed Canadian universities to apply for funding to be able to design and build a nanosatellite, so a very small satellite, and then have that actually launched into low Earth orbit. And this was a really great initiative specifically for students at the undergraduate or graduate level to get hands-on experience on a real space project. When I was in undergrad, I was a participant in a competition called the Canadian Satellite Design Challenge. That wasn't part of this program, but still it was a Canadian-wide initiative, and it was one of the key experiences I had that really allowed me to get this experience, the hands-on experience that helped me get the job at the Canadian Space Agency. And then finally, there's the Space Exploration Directorate. So this is the one that deals with the astronaut missions to the ISS and maybe eventually to the Gateway as well. Our astronomy missions, things like James Webb Space Telescope, planetary science, and of course, robotics. And that includes both future projects and rovers or Canadarm3, as well as the operation of Canadarm2, which is currently on the ISS. So that's the group that I work within. So really on a day-to-day basis, I'm dealing with robotics. Yes. So the context of our work. So one of the questions that you might ask is, why are we going back to the moon, and why are we going to Mars, and what does it all mean, and where did this come from? So yes, we've been to the moon before, but we're really interested in going to Mars, and there's a lot of value to, the scientific exploration and the scientific data we can get from it. But we're not deciding this in a vacuum. We're kind of working together with other collaborators to decide on a roadmap to do so. So that roadmap is sort of coordinated by this group called the International Space Exploration Coordination Group. And one of the really nice quotes that they have in one of their reports is that sustainable space exploration is a challenge that no one nation can undertake on its own. So really the ethos is that we have to work together to do this. And that seems pretty true. Going to Mars is going to be really expensive. It's going to be really difficult. There's a lot of challenges ahead of us to do that, because we need to prove our technologies. We need to prove that we can keep our astronauts safe to do that. And then, all that comes with a lot of money and a lot of effort too, and a lot of knowledge. So a single country trying to take that on itself is a little bit difficult. But when we work together, it makes it a little bit easier to make it a shared journey. So I don't think this is the most up-to-date image, but this was from, I believe, 2020. But this is the group of space agencies that are currently working together on this. And as you can see, there's a lot of new sort of names there. Of course, there's NASA, there's CSA, there's also the UK Space Agency, the German Space Agency, there's the Romanian Space Agency, so on and so forth. Australia, they also started a space agency in 2017. So a lot of new players are in the space, and they all want to be part of this journey. So what does that journey look like? So this roadmap really depicts a story of, we go back to the moon first. We go back to the moon and we create a permanent habitable space station that can be an outpost for our astronauts. We also go back to the surface of the moon. We explore the surface. We start proving some technologies, start building more long-term duration habitable environments for our astronauts. And then we take all that lessons learned and all those technologies, and then eventually we can start looking at going to Mars. So the timeline here, it shows here that we want to get back to Mars by get to Mars by 2040. I'm not sure if that timeline is going to be kept up with, but we definitely are moving towards at least getting back to the moon within by 2030. And so one of the big parts of this is the Artemis mission. And the Artemis mission is sort of a play on the Apollo program. So the Apollo program, as I'm sure most of you know about, was the missions that NASA undertook to put the first man on the moon. And there was a series of Apollo missions to do so. The last Apollo mission, though, was in 1972, which is quite a bit before my time. We want to go back, and that is going to be supported by a new series of missions called the Artemis missions, and this is a NASA-led initiative. They chose the name Artemis because it is the twin sister of Apollo, and just like Apollo stimulated the sort of Apollo effect, which encouraged a lot of young people to consider science and engineering, the spirit of Artemis is that we will have the Artemis effect that will not only encourage young people, but specifically more women into these areas. Something I think is interesting about the Apollo missions is that they focus mostly on the sort of the equator of the moon. What we're interested in now, though, is we're really interested in the south pole of the moon, and I'll explain a little bit more why later. This image is also really interesting because when you compare it to the Apollo era, when it was mostly just, well, here is just a map of the Apollo missions. But in 2020 and beyond, we have a lot more missions that have landed on the surface of the moon from many more actors, not just Russia and the US, but also Japan, the European Space Agency, China, India, Israel, and then soon Canada. So one of the outcomes, as I mentioned before, from the coordination working group is a space exploration roadmap. So we have the lunar orbit, and then we have the lunar surface. So I'm going to talk a little bit more about the lunar orbit. So NASA has led this initiative of creating or developing a space station to orbit the moon. So we're familiar already with the paradigm of having the International Space Station. So the International Space Station has been a really great example of international collaboration in space exploration. It's been in operation and continuously habitated for 20 years. So this is a really excellent success in our eyes for what we can do when we come together. Now the gateway is going to be a little bit different though. So it's not only different because of the location. So instead of being in low Earth orbit, it's going to be around the moon. But it's going to be different in some of the partnerships. So right now, so far, we have ourselves, NASA, the European Space Agency, and JAXA, but also the amount of time it's going to be habitated for. So unlike ISS, which is continuously habitated, I might be using the wrong word, so I apologize. But the Lunar Gateway, it's going to be only crewed for 1 month out of a year. So it's a lot lower of a duty cycle of how long we have crew on board and how often. One of the reasons for this, though, is because of the environment. It's going to be quite a bit more like deep space, which means that the crew on board will be exposed to a lot more of the dangers of the space environment, like radiation. With the ISS, it's still quite dangerous for the crew members in terms of radiation exposure and environmental exposure, but you're still protected by the Earth's magnetosphere. So that's one of the reasons why this is going to be a shorter mission. It's also further away. So if something goes wrong, it's going to be a lot more difficult to provide aid and to get those crew back to Earth quickly. So it's definitely a big change in mindset, but it's still going to be a really valuable opportunity to have crew on board to perform science on the Lunar Gateway. So what is Canada's role? Well, we had Canadarm1, we had Canadarm2, so we're going to do Canadarm3. So we're an expert in not only building space robots, specifically the manipulator type of robot, but we're also really good at operating them. So the operation aspect is actually an expertise that takes a lot to develop and get good at. So and then comparing Canadarm3 to Canadarm2, actually have another slide for this. So a little bit of a history of the Canadarm family. So Canadarm1, it was deployed in 1981 on the space shuttle, and then it was decommissioned in 2011. So it had quite a long lifespan of use. For Canadarm2, this one was deployed on the ISS in 2001 and still operates to the present day. So it far exceeded its expected lifetime, which I think was originally 10 years. And then Canadarm3, we plan to launch in 2027, and our expected minimum lifespan of it is 15 years. But if we look back to Canadarm2, we used it for quite a long time. So if it still functions at the 15-year mark, we'll continue using it as long as we can and as long as the space station is operational. And I really like this picture because it's actually an image of Canadarm1 and Canadarm2. So I believe, if I recall correctly, Chris Hadfield is actually operating Canadarm2 from within the space shuttle. And then there's a crew operating Canadarm2 from the ISS, and they're handing some sort of pallet from, I think, ISS to Canadarm, to the shuttle. So it's sort of like a space robot high five, which I think is like really, really cool to look at and to know that happened. Unfortunately, I think that Canadarm3 will not have the opportunity to high five Canadarm2. It's just going to go right past it, but maybe one day. I guess some quick sort of specs on the size difference between Canadarm3 and Canadarm2. So Canadarm2 is about 17 meters in length and weighs about 1,500 kilograms. And this doesn't include Dexter or the mobile base station. For Canadarm3, it's going to be quite a bit shorter. It's going to be 8.5 meters long. The weight is still to be determined. Another really interesting aspect of the lunar space station is the orbit that it's going to be in. So it's going to be in what's called a near rectilinear halo orbit. And if you're really into details like this, I think it's going to be in the L2 South orbit. So there's 4 possible halo orbits. It's going to be in a lower sort of corner one. So what makes this orbit really interesting is that it's highly eccentric. So at the point that's closest to the surface, it's going to be 3,000 kilometers from the surface. And at the point that is furthest away, it's going to be 70,000 kilometers away. It's also orbiting in a way that it always has a line of sight to the Earth. So this is really useful and important for maintaining communication with the space station. It's also a very stable orbit. It's going to take very little fuel to be able to maintain stability, which is very desirable for such a big mission. And it'll take about approximately 7 days to do the full orbit. So there's plenty of time to observe the surface of the moon, to communicate with assets on the lunar surface, or to do other science in different parts of that orbit. There was actually a CubeSat mission that was actually going to, the plan was to launch it into this orbit to characterize it, and that was scheduled for the end of 2022. I actually have not followed up to see if that did launch, but that is a very interesting use case of a CubeSat. So yeah, so in 2018, the federal government announced funding for our lunar missions, and we ultimately awarded that contract to NDA. Probably not a big surprise. So we've been working with them on that for the last couple of years, since about 2020. So at this point, we're in phase B, which is a preliminary design phase. At the end, we do expect a preliminary design from MDA before we can proceed to the more sort of concrete design of it. There is an Alberta connection, though, which I really like to point out. So a really important objective of not only the Lunar Gateway, the Lunar Gateway, but moment. So a really important objective of the Lunar Gateway is the concept of autonomy. So we're using it as a proof of concept for going to Mars, which means that we really need to prove independence from the Earth and from ground. And so autonomy is going to play a role in that. The idea is that the Lunar Gateway can maintain itself, can react accordingly to changing conditions, and can also, one of the benefits of that is that when we send our crew to the Lunar Gateway station, when they show up, they're not there to do maintenance or to do any housekeeping. They're really there to focus on science. They're only there for a month. Their time is really precious. So autonomy is going to be really important. So that's kind of like 2 pillars of the importance of autonomy, that independence from ground and also preserving time of the crew members for science. For Canadarm3, that naturally kind of pivots us into using AI. So autonomy itself is not necessarily AI, but AI can support autonomy. So in that sense, there's actually a really great Alberta connection. And they worked with AMI, which is the Alberta Machine Intelligence Institute, to develop a data set for collision avoidance. So this is a very big effort. And they made that available freely on the internet. And the idea is that potential collaborators could use that data to come up with potential solutions to the problem of collision avoidance. Now, collision avoidance, just to give you a little bit of background information, for Canadarm2 to be able to work autonomously, it needs to be able to sense the environment and to react to new things. And most importantly, probably to avoid collisions. If it collides with itself or the station, it's not a good thing. So that's actually a very tricky problem, especially when we're dealing with, a robot in space that's many kilometers away from the Earth. if you want more information about that, if you search Trail webinar MDA AMI, you'll probably find a recording of a webinar that was co-hosted by the organizations to talk about this challenge and this data set as well. So hopefully Alberta does not feel left out. You're a very key part of this mission. So yeah, talking a little bit about AI, because I think this is kind of a new thing. You know, Canadarm1 wasn't autonomous. It was fully operated by the crew member on the space shuttle. For Canadarm2, it's also, there's a little bit of autonomy, but only in the sense of scripting. It's not autonomous itself. So it's still mostly controlled manually, either by crew on the space station, usually for scenarios that require really quick reaction time. So like catching a vehicle, you know, you need someone who's close to the action, who doesn't have a leg when they control the arm, or it's controlled from the ground operators, from the ground segment by operators on Earth, in a sort of combined team, both at NASA in Houston and also at the CSA in Saint-Hubert. For Canadarm3, though, you know, it's further away. The time delay, it's in the order of magnitude of 10 seconds. ISS is like 1 to 3 seconds, depending on, you know, circumstances. But the 10-second delay is quite a bit bigger here and much more challenging to control the arm, especially in situations where you need that really fast feedback. So it'll still be operated by crew within the station. That's an option. It can also still be operated by crew on the ground, but it also, our plan is that it should also be autonomous. So what does AI support? So I like to kind of break it down into 3 different categories of functionality that artificial intelligence can support for Canadarm3. The first is sensing. This is sort of detecting the environment, detecting the state of the environment. You know, what are the physical objects around it? What is the state of the arm itself? What position it's in? This is all sensing. It's the way, you know, if you're thinking about yourself as a human, you're doing this all the time when you're walking. You're sensing the sidewalk, you're sensing the environment, the obstacles, if there's a tree in the way, and that sort of thing. AI can also support thinking. So taking in the data from sensing and then making decisions about, you know, or processing what's happening. So you're walking down the street, you see a tree, you're thinking, I should probably move out of the way. AI can support that. And then acting. So the act of moving out of the way also must be done. And it's a little bit different than thinking. So a little bit more concrete examples in the context of space robotics. Sensing might be something like, here in the top image, we have, you see the green boxes and then a red box. This is an image from the ISS where they're using a camera and they're taking 2D images of what's called a grapple fixture target. So you'll see that above sort of this pointy part, there is this thing that looks like a cross, and that's a target. So the way that Canadarm2 right now operates is that it will align with that target, and it knows once it's aligned with the target, it knows it can move in and then grapple the grapple fixture and then take hold of whatever is there, whether it's a payload or a point on the space station itself. So in this image, what's happening is they took the image and they're using some flavor of artificial intelligence to classify what's in that image. And here it looks like they're trying to classify a grapple fixture with a target. So it successfully does that with the green boxes. And then you see a red box. That's something that's not a grapple fixture. It looks like it's some hoses. So that's sensing. That's taking a look, seeing what's there. The bottom image is an example of, it's a prototype rover called Messer. And it's using LiDAR. So LiDAR works the way that sonar works, where if you recall, sonar is when you kind of like throw out a little echo and you hear a ping back. Because we know the speed of sound, we can calculate how long it took to come back. We can calculate how far away something is before it came back. So that's a way to kind of like map your environment. With LiDAR, it's using is using photons. So light is sort of composed of photons, which are tiny little particles of light. And because we know the speed of light, we can calculate, once we throw out a photon and it comes back to our sensor, we can create a map of our environment in 3 dimensions. So something like that can be used on an environment like Canadarm3 be using. Thinking, this is a little bit more abstract, but here is an example of, it is a piece of software that is given a task. So for example, if you want to move your robot from point A to point B, there's actually a lot of steps in between. And traditionally on Canadarm2 and probably on Canadarm1 as well, to go from, to move from point A to point B, our human operators have to actually sit down and write down the steps, each step to do that, and then execute those commands individually. If we're using AI, we can use something like a system that you tell it go from point A to point B, and the AI system knows a lot about, the environment, the steps involved, and it can break that down automatically into the steps that will be required, and then execute them in a way that a human can understand. So here it's essentially moved from point A to point B, and then every single step along the way, like turn the robot on, articulate X degrees, grab a hold of, the other grapple fixture, and then move to that position. So this is a key type of technology that we would need for Canadarm3. And then act. So you'll need to have a reaction to your environment, and that could be different depending on the situation. So for example, if we're talking about collision avoidance, it could be stopping, it could be swerving. We want to be very careful though, so it's probably going to be stopping and moving slowly. But acting is also a key part of that, and another function that AI could be supporting. But that sounds crazy because we don't have AI on Canadarm2, so how do we get there? A more familiar concept is the concept of self-driving in cars. So if you've been keeping up with self-driving vehicles, you know that they're not truly self-driving. There's still a lot of supervision that is involved. But there's actually sort of like this concept of self-driving automation levels, where you start at no automation, which is the way that, at least that's how I drive my cars right now. I don't have a self-driving vehicle. But when I get into the car, I sit down, I have my hands on the wheel, I have my foot on the pedals, and I'm looking around and sensing the environment. I'm thinking about the environment, whether there's a stop sign, whether there's, obstacles in the road, and I'm acting by either pressing the gas pedal or the brake pedal. So that's no automation, and that's about where I'd say Canadarm2 maybe is. It might be a little bit higher than that, but it's really like we really have our hands on the wheel with controlling Canadarm2. And when we first deploy Canadarm3, that'll be the same thing as well. We're going to start with very low automation, and then we're going to move up slowly over time to prove our system is safe and can be controlled before we get all the way to full automation. The goal is that we can, with the dream of self-driving cars is that we can get into our car in the morning, tell it we want to go to work, and then drink our coffee and read our newspaper while the car is doing that. So that is the long-term objective. But before we get there, we do have to take step-by-step small increments in that whole process. A really important concept, though, is that no matter what, humans will be able to take control of the robot, so that we don't get like a HAL 9000 situation, if you're familiar with that movie. So hopefully that kind of gives you a little bit more information or a little bit more context on what it means when we talk about having an AI-powered Canadarm. It's definitely important for autonomy, and it's something we'll take slowly and safely and carefully. Going back to our exploration roadmap, I'll talk a little bit about what we're doing with the lunar surface. So going back a little bit, when I was actually hired at the CSA as a student for the first time, they were in the middle of the lunar exploration analog deployment. And so this was a project where the CSA was building a prototype lunar rover to perform a simulated mission. So this rover was put together with various sensors from collaborators and contractors, such as XIFOS, such as MDA. Canadensys was also involved as well. We built this rover and we deployed some software on it, and we tested it in a rock quarry. So we found a quarry in Granby, Quebec that we were able to clean up and make it look really lunar surface-like. And then over a couple of weeks, we simulated a mission as best as we could. So we really got into, we had a simulated time delay so that when we sent commands to it, we would, the command would take approximately 3 seconds to get there, 3 to 10 seconds, 3 to 10 seconds to come back. We also, an interesting part of this project, we were interested in having multiple ground segment stations controlling it at once, or not at once, but like coordinating together to control it. So we had a ground control center in Germany at an ESA office, so European Space Agency. And then we also controlled it from the Canadian Space Agency just outside of Montreal. So that was really interesting to kind of see, is this possible? What are the challenges with doing that? That's really interesting if we want to work with other space agencies in the future for these missions, because we probably want to work together on controlling it and taking turns with operations. We also did night driving. The moon is either very bright or very dark, depending where you are. So we want to find out the challenges with that, and things like what kind of illumination do we need to be able to get good imagery, to be able to navigate effectively. We also tested some autonomy on this system. So if we go back to the LiDAR, this rover system had a LiDAR sensor on top, and it was able to take a 3D scan of its environment. And then from that 3D scan, it was able to map a safe path about, I think, a couple meters ahead. So it wasn't a very far distance it could move at a time. But we were conservative about it because in a real space mission, we had to be really careful and slow and safe. So we moved slowly, check the environment, move again. So that mission completed in 2019. And it was a really important exercise for us because we went through the whole sort of process of putting together a prototype rover. We designed an operational concept. The ultimate goal, besides operating the rover, was to drive around this quarry and then together with our science team find potential samples to collect. So we collected rock samples and soil samples. We had a little arm that came out and dug out a little sample of soil and put it into a canister. And then at the end of a mission, it would put it into sort of like another container that ideally would then be sent back to Earth in a real mission. So we went through that whole process and learned a lot. And we took all the information and that experience and we're able to feed that into future missions. And that future mission is actually a lunar rover that we're actually sending to the moon. So we announced in, I think, mid-2021 that we were awarding 2 phase A contracts to 2 companies. So one was MDA, the other was Canadensys Aerospace. And in parallel, they both came up with preliminary designs for this rover mission. So we worked with them both over about a year through this process, and we gave them some constraints and some mission objectives. We wanted a lunar rover that would last 1 lunar night and 1 lunar day, and that works out to approximately 2 weeks on Earth. We want the rover to be able to survive lunar night and also to be able to traverse a permanently shrouded region. So yeah, so when we had this announcement, we made this really nice video to kind of, I guess, announce it. And it's using a 3D model of our prototype rover. So the rover that we're planning to send is quite a bit smaller, and I'll talk a little bit about that too. And so this lunar rover mission is actually part of another initiative called the Lunar Exploration Accelerator Program. So the lunar rover mission is just the flagship of it, but we also have funding for other technology and engineering developments. So on our announcement of announcements page, AO. Announcement of, I actually forgot. Okay, so on our page, announcement of opportunities, I couldn't remember what the O stands for. We have an announcement of opportunities page where we post potential funding opportunities. And for LEAP, they fell into several different categories, focusing on health, AI, and robotics and scientific payloads. And the objective with this series of funding is that we fund initiatives in Canada, businesses in Canada, academic institutions in Canada to develop really important technologies, and that can feed forward into making Canada more robust for developing or having a space economy for lunar exploration. So like companies that would have the know-how for different key technologies. And as I mentioned, our flagship is the Lunar Rover mission. So we announced the Phase B contract in 2022, actually just a couple months ago. So we had our Phase A with MDA and Canadensys. They both submitted their preliminary designs, and we had to down select to one of them. So they both were, excellent competitors. They're both very credible space companies. We were building only one rover, so we went with one concept, and that was with Canadensys Aerospace. So the plan at this point now is we're going to continue developing this project. Our plan is to launch as early as 2026, and this is going to be via an initiative called the Commercial Lunar Payload Services Program. We call it CLIPS, and this is managed by NASA. So it's a consortium of private entities that provide essentially flight services to the lunar surface. We're currently in Phase B, and at the end of this phase, we'll have a preliminary design. And the ultimate objective of this mission is to collect science data, to have a technology demonstration, and to also have to perform outreach for Canadians. So some of our scientific objectives, as I mentioned before, we're really interested in the lunar South Pole. So we're currently surveying different sites at the lunar South Pole that make good candidates for actually landing this rover and exploring. We're really interested in being close to a permanently shrouded region, as I mentioned before. And what makes this really interesting is a permanently shrouded region hasn't been exposed to sun. So we expect that there might be volatile compounds there that could tell us a couple of things, the genesis of the materials on the lunar surface. It can tell us if there is ice water there. And if there's ice water there, it can make it a good candidate location for future humans to be, because that could support, a surface habitat and provide, essential resources like water. And all this data will be used for Canadians to research as well. The technology demonstration, that also is a pretty big part of this. So a very unique aspect of this rover compared to Martian rovers is this one is quite small. It's about half a square meter. So if I'm standing, it goes up to about my knee. It's also at maximum 30 kilograms, so it doesn't weigh very much. Martian rovers weigh as much as a car. This one is going to weigh quite a bit less. It weighs less than me. And I'll have 6 scientific payloads on it. So 5 Canadian payloads, 1 American payload from NASA. And currently I know that our Canadian scientific payloads are going to be looking into things like detecting hydrogen, trying to characterize the mineral makeup of the lunar surface, also taking measurements of the radiation on the lunar surface, which is once again really important if we want to send humans there, knowing what are the radiation risks associated with these areas. And we're also very dedicated to outreach. We really want to use this to inspire young people, to inspire Canadians. So we're looking into different ways to make sure that Canadians are engaged throughout the entire process. So we're trying to come up with creative ways to do that, whether it's streaming live from the lunar surface. That might be a little bit tricky, but we're looking into things at that level, having an interactive website, all these sorts of things. So that's a very big part of this. Another thing too is this is very slow. So earlier I mentioned that with these sort of remote missions, we had to move slowly and carefully. This rover is going to move 20 centimeters per second, so you can definitely outrun it probably. It's going to have a 4-wheel drive system. It's going to have solar panels on all sides. Also, of course, antennas. It's going to communicate with the Earth. So to summarize, I hope if you take away anything, you take away that Canada right now is a participant in the global effort to go back to the moon and eventually go back to Mars. And we're really excited to do this on behalf of Canadians and to make sure that Canada continues to benefit from these opportunities. We're going to be participating in Lunar Gateway program. This is the NASA-led space station around the moon, and we're providing Canadarm3. So by providing Canadarm3, we're hoping that we will continue to get access to missions to these stations, similar to how we do on ISS right now. With our contribution of Canadarm2, we do get our flights opportunities with our astronauts on ISS, and that's always a great opportunity for our Canadian astronauts to do some science there too. And then of course, LEAP and LRM. So LEAP being that larger initiative, LRM being the Lunar Rover mission, are part of developing Canadian technologies and scientific capabilities. So we've contracted to both of these missions, both Canadarm3 and LRM. We give these contracts to Canadian industry, but then they also work with other companies, other academic institutions. With Canadarm3, we have the example of Amy as a collaborator on the AI aspect. So it has sort of what we see as like a rippling effect. And that's all I have for now. And thank you so much for your attention.
All right. Thank you so much, Chantel, for amazing presentation. We will move on to some questions. I'll start with a question online. If anybody here in the audience has a question, don't hesitate to raise your hand and Eric will come and take your question. But let's start. And for those of you joining online, just use the Q&A function and I will read out your question. So the first question, is it common for people other than astronauts from the CSA to be physically stationed at NASA or the European Space Agency?
Actually, yeah, it is. We do have a couple of my colleagues actually are at NASA Johnson Space Center right now. Largely there, we have some of our, to kind of give you context, for Canadarm2, the operations team is an integrated team that is both NASA employees and CSA employees. So we work together very closely to operate Canadarm2 on a day-to-day basis. So we do have some of our staff that are located there, usually on a temporary basis for a couple of years while they do some training and while they support various missions for Canadarm2. But we do also have a couple of people who are there permanently, usually as liaisons. And by permanently, I mean they're there for several years until they decide that they don't want to be there anymore or want to come back to Canada. For Europe, I think right now officially we just have our liaison office in Paris, who is there as a liaison to the European Space Agency. So at this time, there isn't that same integration of large teams.
Okay, great. Anybody in the audience here have a question? There's one right here at the front.
What's a Canadarm for?
So yeah, that's actually a really good question. I guess when I think about it, I didn't talk about that. So for Canadarm1, it was used to, for example, when the Hubble Space Telescope had a defect, they were able to fly the space shuttle close to it and use the Canadarm to grapple it and hold it in place while the astronauts worked on it. On ISS, we use Canadarm2 a lot to assist astronauts. So for example, an astronaut can go on the end of the arm and we can drive that arm to a location and allow the crew to work on something. It's also used for example, changing batteries or changing things that need to be replaced on the space station. And it's really helpful because when we send crew out into space, it's very dangerous and can be unsafe. So whenever we can do it with a robot, we try to do it with a robot instead of sending an astronaut outside into space to do it.
Cool. I'll take another one online and then we'll go back to the audience here. The question online, how are modules going to be transported into lunar orbit? They envision special human-controlled rockets with modules attached.
So I think that the Space Launch System is a deep space class rocket that is being developed in the US. So I think parts of it will be launched on that, so a very large rocket. I think SpaceX may be launching some other parts as well. So it gets launched piece by piece. Depending on the size of the piece will determine what rocket is used. So it'll get launched, and then at some point, it'll get detached into the lunar orbit.
Great. We'll take a question from the audience here.
Hi, you mentioned that astronauts can only go in the Lunar Gateway for 1 month. Is it a specific 1 month, or is it because after 1 month, the radiation just becomes too high, or is it just like only July is safe?
I believe it's the time and not the time of year. So I think it's 1 month is probably the max that it's safe. There may be some aspects of space weather that would also influence what month of the year, but I think that's a little bit, it's dynamic. So I don't think there's a preferred time of the year.
Great, thank you. Let's take another question from online. Do you have any project opportunities for high school students?
Good question. I would love to answer that because I think that, we do a lot of outreach with high schools. And I know that there has been some interaction with them and some sort of collaboration, but I don't know a lot of the specifics. I have personally not been very involved with them. But if you send an email to, actually, if you go to the CSA website and find the information email, I think if you contact them and you're a high school educator, they would love to hear from you and to help you initiate some activities.
Great, thank you. Let's take another question from the audience here live.
What is the most dangerous part of a human going to the moon?
I would say it's the radiation. You can't really see it. And it, sorry, and it goes through a lot of materials. So that would be probably, in my opinion, the most dangerous.
Great. Here's a question from online. Is the lunar space program to ultimately migrate millions of people there and support living there permanently? Or is it just to make a backup place or a tourism site as the second place to visit?
At this time, I think our objective is to prove technologies there. So not necessarily to relocate humanity there. But it is possible that, I'm speaking as a space agency, on behalf of a space agency in that perspective. But it is possible that commercial companies will want to, make a resort there, a hotel. That is not something we're planning for, but it is a potential outcome.
Cool, thanks. Let's take another question live here in the audience.
Why are we unable to send humans to the moon as much as we used to? And is that because AI can start doing the jobs they used to be able to do?
Yeah, that's a good question. And I think it's not simple. What I read, because the 70s were a little bit before my time, and I only can read about the 70s and the space program then, it was sort of the public lost interest in people going to the moon. And so it stopped being really interesting. And so funding started to, it was less and less, and then they canceled the program. So I think that was one of the major things. It became too normal, which is kind of like a funny problem to have. But we're excited again, and hopefully this excitement is continuous and can sustain our future activities in space.
Great. Another one online. What are rovers usually made of?
Oh, if you're talking about materials, it's usually a type of aluminum. Could be a material like PEEK, which is a composite materials. That's not actually exactly sure what it's made out of, but there are very, very specific space versions of aluminum and also composite materials that are used for these projects, for rovers and for other space vehicles.
Great. Do we have another question here in the audience?
Hi, I'm wondering about the end effector for the Canadarms. If there are any significant changes between 1, 2, and 3. And you talk about a lot about like grabbing. I'm wondering if it's modular at all, or if it's just kind of like parallel grippers. I'm not sure.
You sound like someone who knows a lot about robotics. I do know that there have been changes between the end effectors for Canadarm3 compared to Canadarm2. I think they resolved some of the perceived, I guess, weaknesses with Canadarm2. I have to admit, though, my background is computer engineering, so I kind of, my role is a little bit more on the avionics and software side, so I have not been very in tune with the mechanical side. So unfortunately, I don't have a whole lot else to say about that.
Oh, thank you. The next question, somebody online asks, what are the requirements to become an astronaut?
Yeah, that's it's a big one. So for our last astronaut recruitment campaign, we required candidates who applied to have a bachelor's degree in a STEM field. So that was science, engineering, I think also nursing and medicine were accepted as well. And the people who tend to be successful in those competitions they usually had more education than just a bachelor's degree. They usually also had a master's degree, were involved in research, had multiple multidisciplinary backgrounds. So not just one type of engineering, sometimes it's engineering and science. So for example, David St. Jacques, I think he had a physics engineering degree, and then he did a PhD in astrophysics. He also has an MD, so he's also a doctor. It's not necessary to be also a doctor, but that would be some of the key things. And then I guess other sort of, I wouldn't say the requirements, but things that make you more likely to be successful in these competitions is being physically fit, having good endurance, because you get put through a lot of physical testing through the whole process of recruitment. Also good in high stress situations. So being able to take in a situation and methodically work out a solution, those are really good qualities. And also sort of your people skills. If you're on ISS, you're going to be, in a space station with other people for months at a time, and you need to be able to both deal with there's like kind of like a dual effect of you're isolated from other people outside of that group. So you're not, seeing your friends on Earth or your family. So being able to deal with isolation, but also being able to deal with like being in close quarters with other people. That is a very challenging sort of characteristic and quality to have. So I think these are all kind of good starting points. But there's not just like one sort of profile for astronauts. So it's really the luck of the draw and how well you can compete in these competitions.
That's interesting. We'll take a question here in the audience.
Hello. So what's the reasoning behind Canadarm3 being much shorter than Canadarm2?
I guess one really big reason, I should have mentioned this, is that the Gateway station is going to be 1/6 the size of the ISS. So having a really big arm doesn't make sense. It would just be really bad for its balance, if you can think of it that way. So a smaller arm made more sense.
Let's take another question online. How long did it take to develop the Canadarms?
That's actually, I don't actually know the answer to that one. But I would imagine on the order of a decade or so for sure.
Cool. Any other questions here in the audience? Yeah, looks like we got one.
Thanks, Chantel. This is really super interesting. My question is, why do we want to go to Mars?
Yeah, that's a really good question. I think that we kind of see human space exploration, it's a really, we perceive it as being a really important sort of scientific goal, to have, we can send robots to these places, but when we put humans there firsthand to see things, to observe things, we can learn a lot more. And I think it's a little bit especially in Canada, in our genes to explore and to explore new territories and extreme environments. So I think it's a combination of sort of this human instinct to want to see more and to see things in person. It's also the sort of benefit of seeing it, firsthand and not through robots and data. I think strategically, keeping up with, well, I don't want to say keeping up because obviously it's not, we have to do what's best for Canada. And right now we think that what's best for Canada is the opportunities that going to Mars will gain us in terms of scientific discovery and knowledge and the technology we have to develop to do it. I guess a more concrete example of why going to Mars might be beneficial for Canada is to get there in the first place, we have to be able to protect our astronauts from radiation. And a part of that could be, dealing with DNA damage. And if we can solve DNA damage, we might be able to solve things like cancer. So there's sort of like this very complex underlying motivation to do it that we look at when we're doing these sorts of things. I hope that makes sense. Sorry about that.
No, that's a great answer. Another question online. Do you know when the Canadarm3 will be ready for Lunar Gateway?
Currently, we're expecting 2027, so not too long.
Awesome. And any questions here in the audience?
Yes, hello. Hi, Chantel. I think I heard you mention about some response delay times of up to 10 seconds for the Canadarm. Just curious, looking to learn what limits these speeds and what, if anything, is being done or can be done to improve.
Yeah, I guess it's just the distance, between Earth and the moon. I think that drives that the most because, it takes time for that signal to propagate all the way there. Even to the ISS, there's a delay, but it's very small compared to the moon. Things that could help resolve that. I know that there are groups that are looking at different, space networks or like a space network highway that can make these delays shorter. I don't know a lot about them, but I do know that some people are looking at this and trying to figure it out because if we do have humans on Mars, having, a fast internet connection to the Earth would be really great. But for Gateway right now, that's not really in our scope of consideration. Right now, we kind of live with the 10-second delay.
Cool. Let's go to another one online. Once the arm is dispatched, what are some contingency plans in the chance that a certain part fails? In general, how does the ISS and the CSA prepare for accidents and unforeseeable circumstances apart from rigorous testing?
Yeah, I guess there's a couple ways to look at, things going wrong. It could be something that goes wrong during an operation. And on ISS, with Canadarm2, every operation is, reviewed multiple times by different people to make sure that everything's kind of careful. And when you're doing an actual operation, you also have multiple people watching that operation. And every command sent goes through a couple layers of people being like, yep, that's good. Goes to the next person, yep, that's good. And then it gets sent to the arm. For Canadarm3 and for Canadarm2 as well, I guess, we have replaced parts on it that have, I wouldn't say failed, but degraded. We've replaced the end effectors at some point. So those are the parts on the tip. So it is possible. We do design it in a way that hopefully at some point, if we need to replace different parts, we can do it. With ISS, it's a little bit, I wouldn't say easier, but we can send things to ISS and swap things out. It still is not ideal. It can be expensive and take a lot of time and effort. For Canadarm3, we definitely are thinking about this. So we try to design everything so that it can be repaired. Every part should be able to, I guess one example is Canadarm3 actually has two arms. So there's a little arm and then there's a large arm. And I realized I failed to mention that. But the little arm's function is to be able to repair the large arm. And the little arm is small enough that can fit inside the station so that crew can fix it. Another strategy is to have parts of the arm that can be interchangeable. So for example, cameras, I think that was a lesson learned from Canadarm2, where if we didn't have the same camera on every part of the arm, if one camera failed, it was really hard to swap it out for another one that maybe is less important. So choosing like, the same camera so that we can swap them out is also another strategy that can help mitigate those things.
Awesome. Do we have another question here in person? It looks like it.
Hi, thanks you for your presentation. It was really good. Is 3D printing being a factor in the new technologies? Like when you were just talking about spare parts, I made a thought, like, are we planning on being able to manufacture parts on this, the lunar rovers, or not the rover, the gateway? Thank you.
Yeah, actually, so not for Canadarm3. The challenge with 3D printing is there's a lot of, when you manufacture a part of the Canadarm, it needs to be very, a certain quality. And I think at this point, 3D printing might not meet that quality. However, 3D printing in space is definitely a huge area of interest globally for different, academic institutions and companies. I've seen companies that are looking at using lunar regolith as a 3D printing material, with the idea that you can 3D print a house or like a shelter. There's also companies that they want to 3D print things in orbit so that, if you want to launch a large, satellite, for example, you have to have a large launch vehicle. And I think their sort of idea is that instead of launching a large space vehicle, you launch your printer and then you print whatever you need in space. And that way you're not dealing with the, large launch capability. So yeah, it's definitely in the realm of interest and possibility in space, but not for Canadarm3 at this time.
Great. Somebody asks online, when will the gateway be launched?
So it's going to be launched in phases. I think the first phase was originally, so we call it the initial phase and the sustaining phase. And if you look at the Artemis missions, there's Artemis 1, which just happened. And that was an experimental test of just the Orion vehicle. So that's going to be the vehicle that'll take crew to the gateway eventually. Artemis 2 will be a crewed test, same thing, but it's going to go around the moon, but not touch down on the moon. And then around Artemis, I think 4, possibly maybe 3, we expect the gateway to start, being there. So the original timeline was that we expected the first part of the gateway to be there around 2024. I am not sure what NASA's timeline is now. I think it might have slid a little bit further along, so it might be 2025 now. But that'll just be like the core parts of the gateway that are just needed just to have humans there. And then Canadarm2 comes in the sustaining phase, and that's when another module and the Canadarm2 will arrive. So it's a couple of stages, but we can probably start seeing things go up around 2025.
Wow. Another question here in person.
How long does it take to build a full-sized rover?
So for us to build our rover, it's going to take about 5 years.
Awesome. We'll take just a couple more questions online and in person. So somebody asks, until recently, space missions and exploration were performed entirely by government agencies. Now, what role do private corporations have to return to the moon? Could you see the lunar vehicle or a space station being designed and deployed entirely by a corporation?
Absolutely. So I guess one really good example is, this isn't necessarily a lunar space station, but there's a company called Axiom Space that is looking into having their own commercial space station, kind of like the ISS, in lunar orbit. And they'll then provide services on that space station. So like if you're a company or a university, you can pay to have an experiment on there. If you are a tourist, you can pay to go visit Axiom Space Station. for the lunar surface or for the lunar environment, I think we're already sort of seeing that. So for example, NASA, they have, so for part of the gateway will be something called the human landing system. It'll be the system that takes humans from the lunar gateway itself to the lunar surface. So that's part of the objectives here. And I believe that the model for that is they called it a private-public partnership, where they just pay for a service of human landing system. NASA itself isn't owning it. So that, I guess that's one example of a commercial entity sort of providing services in the space environment. But yeah, I think it is possible we'll see commercial space stations or commercial rovers on the moon and around the moon as well.
Great. Do you have any questions here in person? No, I'll take another one online, and we'll wrap up our Q&A. Does the CSA have any plans for other major projects other than Canadarm3 and the lunar rover that you mentioned?
Absolutely. So we're always kind of keeping an eye out on potential opportunities for us to participate in missions or to have our own mission. In terms of robotics space exploration, I'm not sure. We're definitely thinking about the next step in terms of rover exploration. So we're already kind of thinking about, ideas of what comes after LRM. We haven't thought about what comes after Canadarm3 yet, like kind of vaguely, but we haven't announced a Canadarm4 or anything like that. But I know in other departments, for example, in the space utilization group, Earth observation is a really big initiative that we're expecting a lot more projects to start happening in. So Earth observation is our missions that observe the Earth. So like it can be taking images of the Earth's surface. It can be taking measurements. WildfireSat, for example, it's a satellite that will detect fires, forest fires in Canada. So that's a really big priority, I think, for the space agency that's coming up, and you'll probably see more things related to it.